Today we're going to talk about two other rules, the power rule and the distributive rule. So if you look on the page, your exponent properties rule, we'll start there. From yesterday, you did the quotient rule. So this is a power rule. If you'll notice that we have a base of 2, and it's raised to the second power, and then that whole amount is actually raised to the third power. So we're first going to write it with repeated addition. So what is being raised to the third power is 2 to the power of 2. So we write 2 to the power of 2 once, twice, 3 times, and then expand that. 2 to the power of 2 is actually 2 2's. 2 to the power of 2 again is 2 more 2's, and then 2 more 2's. So we have a total of 6 2's. So we keep our 2 to the power of 6. So let's try this one. So we have 5 to the third power raised 4 times. So 5 to the third power is actually being multiplied by itself 4 times. So we have 5 to the third power times 5 to the third power times 5 to the third power, and then times 5 to the third power. We expand that further. We have 5 times 5 times 5, 5 times 5 times 5, 5 times 5 times 5, and then 5 times 5 times 5. So if we count that all together, we actually have 12 pieces. So if you start noticing, what is actually happening here is we are taking the power that's out here of 4, and we're multiplying it by the power of 3. 3 times 4 got us 12. So we keep the base, and we multiply the exponents together, or the exponent by its power. So if we notice here, we have 7 to the 12th. We know we had to have 7 12 times. So 7, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, squeeze one more in here, 12. So we had it 12 times. So we can think about how can we break that up in order to get our first repeated addition. What could we have? So we could have had 7 to the third, and that would have given us 4 times. We could have done that a couple of different ways. So we could have had 7 to the third 4 times. Which means we would have had 7 to the third to the fourth. 4 times 3 got us 12. Okay, so if we work backwards here from x to the 6th, and we had that 4 times, what we really had is x to the 6th raised to the 4. Now, if we place all of those out, when we think about this rule here, we've already learned this rule. When we have like bases, we actually add all the exponents. So 6 plus 6 plus 6 plus 6 gives us 24. The same way as 4 times 6 gives us 24. So I'm just going to leave this box. We don't really have a whole lot of room for that. So we're going to make it x to the 24th. Now, when you get to where you have numbers with variables and being raised to a power and a variable raised to a power and then the whole thing raised to a power, you have to affect each one. So this is 3 to the 5th, and we're raising it to the third. So we have 3 to the 5th times 3 to the 5th times 3 to the 5th, and then we also have y to the 2 3 times. So y squared, and y squared. Then we can extend it out. Don't have a whole lot of room. Very big to write right here. So we think about what can we do to go ahead and take this. Well, these are like bases, the 3's. So we're going to keep the 3. And this is multiplying at this point. So 5 plus 5 plus 5 is 15. So 3 to the 15th. And then y, 2 plus 2 plus 2 is 6. So if we would have just looked from the beginning at our situation at the start, we could have seen, well, we had 3. 3 times 5 gave us 15. That's how we got 15. And then 3 times the 2 got us 6, and that's how we got the 6. So we keep our base. So if we look now at the one that's way too large, we're going to think about what can we do? Well, we keep the base, and we raise each power by the power, by multiplying. So 20 times 32, I'm going to work that one out. 2, 0, 4, 0, 6, 640. We definitely wouldn't want to write all that out. So we have A to the 640th power. Very large number. So a general rule that we're going to think is we take and keep the base, and we multiply the exponent or exponents by the power. So how is this different from the product rule? Well, in the product rule, we add the exponents when we're multiplying. So product rule, we add exponents. When we multiply. And we're going to come up with a rule. We're going to do that on our yellow sheet in just a minute. So we're going to move on to our next property, which is very similar to this one. This is a distributive rule for products, and this is very similar to what we just learned with the power rule. And we notice here we have 2 times 3 inside raised to the third power. So we're writing 2 times 3 in parentheses 3 times because that's where that 3 came from. We rearrange the 2's and put them all together, all 3 of our 2's together and all 3 of our 3's together. And then we can say, well, we have a base of 2, and think about them having an exponent of 1, 1, and 1. So we have 2 to the third power, and then the base of 3 to the third power. So we can do the same thing for the second one. So we have 4 times 6 times 4 times 6 times 4 times 6 times 4 times 6. So here we think about all of our 4's. We're going to rearrange them. We actually have 4 4's. And we have 4 6's. So we actually have 4 to the 4th power and 6 to the 4th power. Now we can simplify this even further by figuring out what 4 to the 4th power is and 6 to the 4th power and get a whole number if it asks us to simplify as a number. So we can think the same thing here. X times y, and we have that 5 times. However, if we think back to the rule we just learned, we can think about a little bit easier fashion and make it a little simpler for ourselves. So this is still affecting each piece. Now we can simplify in here first, and we could be rewritten as xy to the 5th power without the little dot. But this has to affect this exponent and this exponent. Well, right now you may think, well, where's the exponent? But remember, it's a 1. So x to the 5th and y to the 5th would be our answer. Much quicker than writing all that out. So the same thing here. This has to affect the 3 and the 4 and the 5. So we'd have 3 to the 2nd, 4 to the 2nd, and 5 to the 2nd. We can then simplify that further. If we know 3 to the 2nd is 3 times 3, that gives us 9. 4 to the 2nd is 4 times 4, which gives us 16. And 5 to the 2nd is the same thing as 5 times 5, which gives us 25. And then we add all of those together. So we have 9 plus 5 gives us 14. And then plus 6 more gives us 20. Carry our 2, 4, and 5, and we've got 50. All right, so the next one, we have a variable and a number. So remember, we have to affect every piece. So this would be 3 to the 6th power, and then x to the 6th power. We could then simplify down 3 to the 6th power with our calculator if it asks us to put it in simplest form, and then leave x to the 6th alone. So you can do that. So our rule of the things that are a little bit different here is that we can think about simplifying first in the equation or inside the parentheses and then applying. That's easiest the thing to do. But each piece has to be affected. So all pieces must be raised by the power. So when you think about distributing, why do you think it's called distributing rule? Remember when we talk about distributing in general, each piece has to be touched. It's just like playing basketball. So if we're doing 4 and we have an x plus 2 in here, distributive means 4 is being touched here and 2 is being touched here. Same thing with our rule. When we have 3x, 4, and then we're raising it to the second power, the 3 has to be touched and the 4 has to be touched. So all the pieces have to be touched. So the rules are very different from what we talked about yesterday. You need to make sure that you understand each rule. Making a flashcard will help you. So we're going to continue on and do a couple little before we do our add to our yellow sheet. So this is one of the practices you're going to do today. You actually have the bottom of page 8. There's a few there to simplify and solve, evaluate. And then you have page 9 here, the polynomials and monomials. And we're going to talk about just doing a couple of these together. So I want you to try to think about what you would do to fill in up here with your step 1 and step 2. So try those out on your own. And then we're going to talk about using some of these rules. So these should get to the point where you're not having to write all this stuff out. It should become automatic. So the first one, we have an exponent of 5 on the outside, and inside we have x squared. So we are actually going to just multiply 5 times 2. So we get x to the 10th power. On this one we have c, and then we have a d. C has an exponent of 1. Remember, we don't see it, but it's there. So we've got to apply that 3 to it. So we have c to the power of 3. And then d has a 2. So 2 times 3 is going to give us 6. Okay? So we're going to go down to one that has more pieces. So number 3. We always take care of what's in parentheses first. And so this is being raised, parentheses, then exponent. So we're going to leave this negative 4 out there hanging out for a few minutes. And we know this is m to the first power, and it's being raised to the 3. N to the 4th power is being raised to the 3. That's them individually. So we end up with m to the 3rd power. We multiply 4 and 3, we get n to the 12th power. And then this whole thing, now that we've simplified it, is being multiplied by negative 4. So we can think about, we have negative 4 times everything that's in here. Well, this is being multiplied. So we can look at this as a negative 4, m to the 3rd, n to the 12th. That affects all pieces. So when we go to number 4, if we look, 2 is raised to the 1st power. It's got to be multiplied. So we think about 2 to the 1st. It's now being raised to the 5th. 2 times 1 times 5 is 5. So we have 2 to the 5th. 5 times the exponent of 2 is x to the 10th. And then we just have a 1 there, so we get y to the 5th. Okay? We're going to do one more, actually a couple more, with our negatives here. So this is a negative 3, and it's being raised to the 3rd power. So think about this separately. This is a negative 3. It has an exponent of 1, and it's raised to the 3rd power. Remember, each piece. And then this is x squared, and it's also being raised to the 3rd power. So this is a negative 3 times negative 3, I'll use my parentheses there, times negative 3. Because when we get 3 to the 3rd power, we're going to have a negative times a negative is a positive, times another negative is a negative. 3 times 3 is 9. 9 times 3 is 27. So this actually can factor down to 27 as a negative. If it asks you to simplify all the way down, which you should do, then you need to get it as a whole number. We haven't done that a whole lot yet, but we can actually go back and do this one to the 5th power the same way. So then we're going to have x squared raised to the 3rd power, and we get x to the 6th. Okay, and this would be your final answer, simplified version. So number 6, I want you to try to do that one on your own for a second, and pause the video, and then come back and see how you did. All right, so here's your final answer. I broke these down so you could see what each piece happened. So 1/2 raised to the 3rd power, we get 1/2 times 1/2 times 1/2, so that gives us the 1/8. And then a to the 3rd raised to the 3rd power, 3 times 3 is 9, we got a to the 9th. B to the 4th raised to the 3rd power, 4 times 3 is 12, we got b to the 12th. And then c to the 5th power raised to the 3rd, we got c to the 15th. This would be our final answer. Okay? All right, you're going to complete the rest of this sheet, and please check Canvas. You have page 11 and 12 to do where you're working with the same things. You need to try each one. We will go over them in detail in next class.